Oh hey, you must be here wanting to talk about slope intercept. Let's go do that right now. Welcome back to the functions unit. Today we're going to be talking about slope intercept form. So let's go ahead and take a look at a few things we need to remember. So a few key things that we need to remember. Remember first that slope measures the steepness of a line. The y-intercept is where the line crosses the y-axis. And if we have both the slope and the y-intercept, then we can graph a linear equation. So let's take a look at what slope intercept form is. So this is slope intercept form. Y equals mx plus b. Some of the things on there we already know what they are. Some things are new to us, and we're going to label those all now. So we know that y is the output. That's nothing new to us. We know that y is the output. We've learned that before. So y is our output. We know that x is our input. We know that as well. So those are the things that we know. We know that our y is our output, x is our input. The things that are new, we know that now that m is going to stand for slope. So m is going to be our slope, and b is going to be our y-intercept. So when we have slope intercept form, it simply states that we're going to have an equation that has both the slope and the y-intercept in it to help us find our output. So let's see that in action in example A. So here we are at example A, and it says graph the linear equation without using a table of values. So in previous graphing of linear equations, we would set up a table of values. We would select some x's, plug them in, and then graph our points and then connect them. But we don't have to do that if we have slope intercept form. So if we're able to get our equation into slope intercept form, we don't have to make a table. We just need to know that our y-intercept is here at the back. That's our b, our -3. And our slope is here next to the x. That's going to be 2. So the first thing I'm going to do is make a point at the y-intercept. That's where it crosses the y-axis. So it's going to cross at -3. So I'm going to put a point at -3. Now since I know my slope is 2, that just means that we're going up 2 over 1. So I'm going to go up 2 over 1 and put another point. Up 2 over 1 and make another point. Up 2 over 1, make another point, up 2 over 1, up 2 over 1, up 2 over 1, and see I've made a line. I could do the same thing going the other direction. I could go down 2 over 1, down 2 over 1, down 2 over 1, and notice that I've made my line that goes all the way through my points here, all the way through my graph. So I'm going to now connect my points using a straight edge or a ruler. A little bit challenging here, but hopefully you have a straight edge with you. And notice that I've made my linear equation and I didn't have to use a table of values. Now we're going to try the same thing for the second one over there. Again, I've got my b, which is going to be +3. So I'm going to put my point at +3 this time. And my slope here at 1/4 next to the x. So it's going to go up 1 and over 4. So I'm going to go up 1 over 1, 2, 3, 4 and put a point. Up 1 over 1, 2, 3, 4, and put a point. Up 1, oh, that's going to go off my graph, so I'm going to need to go down 1 over 1, 2, 3, 4, down 1, 1, 2, 3, 4, and that is off my points, so I see I've got my points there, and now I've got a straight line as well there, so I'm going to connect my points using a straight edge. Draw my arrows to show that my line goes on forever and ever, and notice that I've made two linear equations without having to draw a table of values. It is much faster this way. Will a table of values work? Yes, but this is a much faster way to get that done. Now let's make a linear equation using a table. So here in example B, it says using a table, create an equation in slope intercept form. So again, we know the slope intercept form is always going to start with y equals. So I could put y equals for both of my equations there. I know that's where we're going to start. The next thing that I'm going to do is I'm going to locate my y-intercept. So my y-intercept is wherever x is going to be 0. So on one table I've got 0, -1. On the other table I've got 0, 7. Those are my y-intercepts because that's where x is 0. So on one equation I'm going to have -1. On my other equation I'm going to have +7. So now I need to calculate my slope. And I figured out how to find slope on a table before. I need to find the differences between the x's and the differences from the y's, and it's going to be y over x. So I've got here from -2 to -1, that's a +1. I got negative 1 to 0, that's a plus 1. From 0 to 1, that's a plus 1. And 1 to 2, that's a plus 1. So I know that my x value for this graph is going to be 1, or my change is going to be positive 1. Then I'm going to do the same thing with the y. So to go from negative 5 to negative 4, or negative 9 to negative 5, that's a plus 4. From negative 5 to negative 1 is a plus 4. From negative 1 to positive 3, plus 4. And from 3 to 7, plus 4. So I have 4 over 1, which simplifies to 4. So my slope is 4, and my input is x, so it's going to be 4x. And notice I've got my equation now in slope-intercept form from the table. So let's do the other one. I've got y equals plus 7. So now I'm going to find the changes in x. So going from negative 6 to negative 3 is a plus 3. Negative 3 to 0 is a plus 3. 0 to 3, plus 3. And 3 to 6, plus 3. So I know that we're going to be starting with x as 3. Now we're going to do the same thing with our y's. So from 5 to 6, plus 1. 6 to 7, plus 1. 7 to 8, plus 1. 8 to 9, plus 1. So I'm going to have 1/3 as my slope here. So 1/3 x. And notice now I have both equations in slope-intercept form using my table of values. Now let's take a look at graphs to make our slope-intercept form. So here I've got a couple of graphs, and it says, using the graphs below, identify the slope and y-intercept and write them as an equation in y equals mx plus b form, or slope-intercept. So I'm going to start on the left-hand side. I've got a graph there, and the first thing I'm going to do is start with my y equals, because I know whenever I write in slope-intercept form, I'm going to have y equals. The next thing I'm going to do is go to my y-intercept, so where is it crossing along my y-axis? And it's crossing right here at positive 2. So I know the end of my equation is going to be plus 2 because that's my y-intercept, or where it crosses the y-axis. And now I need to calculate my slope. And to do that on a graph, I'm going to just start at my y-intercept and count up and over till I get back to an integer coordinate. So I'm going to be going up 1, it looks like in this case, and then I can go over 1, 2, 3, 4, and have another integer coordinate. So up 1 over 4. Let's check it again. So up 1 over 1, 2, 3, 4. Yep, I'm back on my line. So my slope is up 1 over 4, and don't forget to put the x for your input. So the first equation is y equals 1/4 x plus 2. Now let's try it on the other side. The first thing I'm going to write is my y equals, because slope-intercept always starts with y. Go down along the y-axis to find my y-intercept. Looks like it's right here at negative 2. So the back of my equation is going to be negative 2. And now I need to find my slope by counting. So I'm going to go notice that my line is going from left to right is going down. So I know I'm going to have a negative slope as my line is going negatively. So now let's count. I'm going to go down 1, 2, 3 over 1. Down 1, 2, 3 over 1. So I've done it twice. So it's down 3 or negative 3 over 1, which simply reduces to negative 3. So I could have either y equals negative 3 over 1x minus 2, or I could simplify my equation and have y equals negative 3x minus 2. Either one is correct. Now let's move on to the last slide where we're going to take equations and move them into slope-intercept form. So here we are. It says, using the equations below, write them as an equation in y equals mx plus b form. So while we already have equations, we can tell they're not in our slope-intercept form. They don't have this y equals mx plus b. So we're going to have to do that. And in order to do that, we want to make sure that we get the y by itself. So we're going to be solving for y. So we're going to draw a wall down from our equal sign. And remember, we're trying to get the y by itself. So we're going to have to move everything else away from the y in order to make that happen. So the first thing that I'm going to do is remove that 5x. So I'm going to subtract 5x from both sides, subtract 5x from both sides. These are going to cancel. Since I can't take 5x away from 6, I'm going to be bringing down my 2y, bringing down my 6, and then bringing over my 5x. So that's the first step of my moving everything to one side. Now I need to get rid of that 2. So in order to get rid of 2, I'm going to do the inverse operation. So I'm going to divide both sides by 2. But I can't just divide the 6 or the 5. I have to divide both. So I have to divide the 6 by 2 and the negative 5x by 2 because I can't just divide one or the other, and I can't combine the 6 and the negative 5 because they are not like terms. So the 2 divided by 2 is going to get it alone, and we're going to have a y. 6 divided by 2 is going to be 3, and then negative 5 divided by negative 2 is going to result in a positive, but it is going to be a fraction. I can't simplify 5 over 2, so I'm going to end up with plus 5 over 2x. So 5 halves x, and now I'm going to write it in standard form or slope intercept form. So y equals 5 half x plus 3. And notice I can change the order of the 5 half x and 3 because of the commutative property that allows me to move the order of addition around. So the answer I'm going to go with is y equals 5 halves x plus 3. Now let's do the same thing to the other side. I'm going to draw my wall down from my equal sign, and again, I'm going to try and get my y by itself. Now the good news is the y doesn't have a coefficient here. It has no number in front, so I'm not going to have to do that weird dividing thing on the other side. But I am going to have to get rid of that negative 1/4 x. But since the negative 1/4 x, I'm going to do the opposite, which is add 1/4 x to both sides. And again, I can't add 1/4 x and 2. They're not like terms. So these are going to cancel, bring down my y, and since I can't add the negative 2 and 1/4 x, I'm going to just go with negative y equals positive 1/4 x minus 2. And again, it's already in slope intercept form. I don't have to do that weird dividing thing. So my final answer is y equals 1/4 x minus 2. That brings us to the end of this set of notes. If you like this video, go ahead and throw us a thumbs up. If you love this video, go ahead and throw us a sub, and we will catch you in the next one.